Welcome back to the Active Run, everyone. Today, we are entering the absolute bleeding edge of Cambridge exam prep. Think of this as your ultimate speedrun tutorial, your high-level strategy playbook for the AS and A-level Mathematics 9709 syllabus. I am your host, your optimization specialist for this run, and our core objective today is ruthlessly simple. We are maximizing your marks against the clock. If you look at our virtual HUD right now, you'll see the active run timer counting down and our mark velocity tracker. That's your marks per minute, waiting to spike. Today's boss fight, one of the most foundational yet heavily penalized areas of the entire game, differentiation. Specifically, we are zeroing in on the derivative of x to the power of n and the tactical deployment of the chain rule. We aren't just doing math today. We are looking at how to optimize your problem-solving frameworks, deploy rapid frameworks, eliminate wasted actions, and completely conquer those high-tariff calculus questions before that time limit hits zero. Let's get right into the mechanics and optimize this route. Look at this patch note straight from the developers. And by developers, I mean the principal examiners. These state explicitly that mastering differentiation, specifically the derivative of x to the power of n and the chain rule, is absolutely essential because it appears in every examination series. Listen to me. This isn't a random number generator situation. This isn't a topic that might spawn if you're unlucky. It is a guaranteed fixture on the map. And because it's 100% guaranteed, it makes it the single most critical area to optimize for your exam day. If you can streamline your mathematical execution right here, you bank precious time, buffer time that you can spend on the much trickier, completely unfamiliar mechanics they throw at you later in the paper. We are going to deconstruct exactly what the examiners are looking for, ensuring your calculus loadout translates directly into maximum mark velocity. All right, here is our map layout for the run. First, the core principles of differentiation. Second, we hit the procedural framework. Third, we navigate the top 3 examiner warnings. And finally, we execute the deconstruct solve strategy. Let's go. Phase 1, the core principles of differentiation. Time to shift your mindset from just solving equations to actually hunting for targeted points. Before you even drop into the paper, you have to understand the back-end architecture that examiners use to grade you. Your mark scheme is hard-coded with 3 specific assessment objectives, or AOs: knowledge and understanding, application, and analysis. And let me tell you, misallocating your time across these 3 domains is the #1 time sink I see in competitive runs. Let's look at the telemetry from 2 players we're coaching. We've got player 1, Alex. Alex gets completely bogged down detailing secondary evidence points. Alex wants to slow down and meticulously prove every basic textbook definition, trying to farm points in the knowledge and understanding zone. It's a massive time loss. The clock is ticking. Then we have player 2, Sam. Sam is a fast writer. Sam moves at high speed, skips the setup entirely, and rushes straight into application, trying to pull off a frame-perfect skip to the final answer. But because Sam skipped the command word parameters and the clear logical steps, Sam triggers massive marking penalties. The Cambridge assessment framework heavily prioritizes analytical depth. To secure full marks and keep your mark velocity high, you have to balance all 3 domains flawlessly. You have to show you know the chain rule, yes, but more importantly, you have to show you can analyze the specific scenario and apply it without skipping the mandatory checkpoints. Now, check out this insider intel we pulled directly from the principal examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. This right here, this is your combo multiplier. The core principles of differentiation aren't meant to be played in isolation. The examiners want to see you chain your moves together. They want to see you integrate your differentiation skills with other syllabus areas. If you can seamlessly connect your derivative to coordinate geometry, to kinematics, or to finding the nature of a stationary point on a heavily contested curve, your score accelerates exponentially. If you just throw down a basic x to the n derivative without linking it back to the larger context of the physical problem, you completely drop your analysis multiplier. You must weave these mathematical concepts together if you want to secure those top-tier A-star marks efficiently. Phase 2, the procedural framework. Let's look at the technical methodology to lock in those critical method marks, even when the pressure is maxed out.
Okay, we need to talk about the method mark strategy. This is basically the checkpoint system of the Cambridge exam. Why do candidates wipe on multi-stage calculus problems under pressure? Because when that active run timer flashes red, absolute panic sets in. There's a massive temptation to do the entire chain rule in your head and just slam the final answer onto the page. That is a terrible route. Method marks are awarded systematically for the correct analytical process and for showing clear working, completely independent of your final answer. They are your safety nets. If you attempt a high-speed skip, do the math in your head, and make one tiny arithmetic error, like dropping a negative sign, you lose everything. You score a 0 for that section. But if you use our structured procedural framework, you lock in the method marks at every single checkpoint. Even if your final answer is off by a fraction, your mark velocity remains incredibly high because you secured the process points. Multi-stage analysis is punishing, but relying on a structured process guarantees you bank points every step of the way.
This is it. This is the 5-step standardized optimal routing sequence you must memorize. 1. Identify key elements. 2. Apply relevant principles. 3. Execute analysis with clear working. 4. Verify results. 5. Present in an appropriate format. Let's pull up the VOD from yesterday's co-op challenge arena. We had Alex and Sam working together live, trying to clear a heavily nested paragraph layout before their screen buffer locked out. They were debating the fastest structural path. Alex, again, wanted to slow down, over-explain the derivative rules, and write out long descriptive fluff. Sam was yelling to throw a high-velocity analytical thesis link onto the page immediately to maximize score acceleration. They were actively challenging each other's movements. The solution? This exact optimal route. Step 3 is where the magic happens. Executing analysis with clear working means explicitly writing down your substitution for composite functions. You establish your inner function, you differentiate it visibly, and you show the multiplication. When Alex and Sam finally synced up and adjusted their paragraph topic sentences to hit these exact mark scheme checkpoints, their clear times plummeted and their scores maxed out. Systemize your logic and the examiners will heavily reward you. Phase 3, the top 3 examiner warnings. We are pivoting to the pitfalls. These are the run killers. Time split check. Okay, before we execute this final top band paragraph and lock in an A-star grade velocity, you need to optimize your subscription feed. Subscribe to Ace the Exams right now and turn on all notifications. Ring that bell. Whether you are running IGCSE, O-levels, AS, or A-levels, this channel is your central tracking hub to outpace the clock and beat the examiners. Do it now, and let's get back to the run. So, looking at the master interface, we see the top 3 examiner alerts, the biggest performance leaks sourced directly from the examiner reports. Exactly a third of students lose marks by confusing cause and effect. In the chain rule, this means mixing up the inner function and the outer function, applying the damage to the wrong mathematical layer. Another third wipe out by forgetting format and presentation. This means sloppy notation. Writing y equals instead of dy over dx equals after taking the derivative breaks the logic chain and triggers a penalty. The final third, answers not specific to the context. If you are calculating the rate of change of a physical object, and you leave your answer as a generic algebraic expression without relating it back to the specific units or the physical limits, you bleed out that final evaluation mark. Let's look at how a structural roadblock happens mid-paragraph and how to fix it. We watched Sam's VOD earlier, and mid-response, their evidence dropped completely out of alignment, absolutely tanking their mark tracking. Why? A massive performance leak, consistently confusing key terminology. You hemorrhage marks by throwing down a massive, high-level calculation without establishing what your variables actually are. The optimal, examiner-compliant execution is to always define your terms before using them. If you assign the letter u to an inner function, you must write let u equal on the paper. It takes literally 2 seconds of active time, but it deploys a structural optimization template. It smoothly transitions into your analysis, ensuring the examiner can effortlessly track your logic from start to finish without any alignment issues. It's how you build a pristine, high-scoring block of text. Phase 4, the deconstruct solve strategy. Time for the overarching problem-solving methodology. I am handing the controls over to you right now for an interactive time trial workshop. This is the 5-minute paced tactical approach for high-tariff command words. Imagine that 60-second countdown timer flashing rapidly on your screen. Minute 1, identify the given information. Scan the text block. Extract the exact variables and boundaries. Minute 2, break it into logical steps. Are we using the chain rule, product rule, or quotient rule? Make the decision fast. Minute 3, solve systematically. This is where you lay down the clear working to capture those method checkpoints. Minute 4, check for reasonableness. If you are tracking the velocity of a particle and your derivative says it's moving at 10,000 meters a second squared on a gentle curve, your power downshift is bugged. Catch the glitch here. Minute 5, make justified recommendations. Tie it back to the physical context. Pacing yourself with this exact framework prevents the panic-induced RNG that destroys standard runs. All right, challenge 2. In our interactive time trial, spot the performance leak. I'm going to describe a flawed sample student response, and I want you to spot exactly where the descriptive fluff or bad pacing costs 4 critical marks. Here's the setup. The student needs to differentiate the quantity 3x plus 2 all squared. They write down 2 times the quantity 3x plus 2. Did you spot the leak? I'll use my digital highlighter here. Boom. They completely forgot the chain rule's inner derivative. They missed interpreting the nested relationship. They didn't multiply by the derivative of the inside function, which is 3. The optimized correct output is 6 times the quantity 3x plus 2. That single missing step, that single dropped multiplier, wiped out all their method marks. You have to extract the data, identify the relationships, and apply the complete theorem every single time. Before we hit the final boss screen, you need a retention strategy. When the exam clock starts and your adrenaline spikes, complex syllabus concepts can get foggy. You need a fast access memory hack. Create a mnemonic for the derivative of x to the power of n and the chain rule using the first letters of key concepts. Something like power down, power less, multiply inside. Whatever custom loadout fits your brain perfectly. Having this mental macro ready to trigger means you instantly recall your theoretical foundations, and you never stall out on the starting line of a high-value question. We are at the victory screen. Alex and Sam just completed their final high-scoring response paragraph using these exact strategies, and their mark velocity tracker just hit a flawless 100%. To distill this entire session, here are your 3 universal optimization rules. Rule 1, the 60-second command word scan. Never start writing until you know exactly what the examiner is targeting. Rule 2, the marks per minute budget allocation. Use the deconstruct solve framework to efficiently capture method marks at every step without wasting time on fluff. Rule 3, the final quality review pass. Always check your output for reasonableness and formatting compliance. So here is your final challenge. Which stage of the deconstruct solve evaluate framework will you optimize first to stop wasting time and start locking in higher grades? I want you to subscribe to Ace the Exams right now. Click that notification bell for our weekly speedrun tutorials, and drop a comment below telling me which specific Cambridge unit framework you find the hardest to clear under time pressure. Get out there, apply this playbook to your past papers, and absolutely dominate your next run.